Alright, we're going to talk about even and odd functions. Alright, so we're going to talk about how to determine if a function is even or odd by its graph and then by using algebra. So for the graph, your graph is even if it's symmetric about the y-axis. So this graph is even because it's symmetric about the y-axis. Or maybe this graph, symmetric about the y-axis. Function is odd if it's symmetric about the origin. So if you can spin your graph around using the origin as the center point, then it is an odd function. So maybe this graph. Odd functions. You can spin it using the center as the origin. Your graph can be neither. It doesn't have to be one of those two. If it's symmetric about the x-axis, that's neither of those two. If it's symmetric but not about the y-axis, so maybe if you move the parabola over, it's no longer symmetric about the y-axis. Or same for odd. It could be symmetric, but if it's not about the origin, it doesn't count. So if I move this graph up, now the center point is not the origin, so it's no longer odd. Alright, so that's graphically. If we're going to do it using algebra, we're going to do this. Okay. So, an even example. Well, first, you're going to replace your x with negative x and you're going to simplify. It is even if you end up with the same exact function afterwards. It is odd if you end up with all the signs opposite. And it's neither if you get anything else, if they're just different. If only one sign changed, it is neither. It has to be all the signs changed to be odd. Right? So if I started with negative x plus 5, and when I'm done I got x minus 5, that would be odd because the x became positive and the 5 became negative. Both signs changed. If I started with negative x plus 5 and I end with x plus 5, that's neither because only the x changed, not the 5. I'm going to do an example for each of those. So we'll do this one. And then we'll do this one. Alright, so for this one, replace all the x's with a negative x. And then simplify everything you can. And with this one, I can simplify this part. Anything in the absolute value becomes positive. So that negative x just turns back positive because of the absolute value. So if you compare the first one to the last one, they are exactly the same, making this an even function. For the middle one, replace all my x's. Example. I'll do this example. So replace everything with a negative x. Don't forget that anytime you have a negative x, technically you have a negative 1x. So I'm going to break that into 2. 2 times negative 1 is negative 2. So compare the beginning to the end. I see that all my signs changed, which means it is odd. In my last example, make all the x negative. If I compare the beginning, positive 3, positive 5, negative 3, but still positive 5. So only one sign changed. So that means it has to be a neither. They didn't all change. And that is how you do it with algebra.